So good morning all of you TyBsc student. Welcome to again lecture series on TyBsc Physics. We have to see here the subject which is solid state physics, and we want to continue the first chapter, that is the crystalline state, and we have to interesting here see all the crystal may be classified into the seven system. So that which are these seven system in three-dimensional space system. So that in this seven system, the first system is the cubic system. First system consider as cubic system. Next system which is considered as the tetragonal system. Next main system which is considered as orthorhombic system. Third one which is considered as orthorhombic system. Fourth one system which is considered as the rhombohedral system. Rhombohedral system. Next system which is considered as hexagonal system. At fifth one system which is considered as hexagonal system. Next system which is considered as triclinic system, and next or last which is considered as monoclinic system and triclinic system. So 6 number which is considered as monoclinic, and 7 one which is considered as triclinic system. So these are 7 different system which is considered as three-dimensional space lattice. So that consider as cubic system, tetragonal system, orthorhombic system, rhombohedral system, hexagonal system, monoclinic system, and triclinic system, and that shapes of their unit cell which is considered or which is see here, and what is the condition between vector a bar, b bar, c bar, and what is the angle between alpha, beta, and gamma, which is see detail in this system. Now we want to see here first system which is the cubic structure, and that cubic structure, that crystal structure have that three lengths are unit, the all three length of the unit cell which are equal are at the right angle to each other. That means that vector a bar is equal to vector b bar is equal to vector c bar. That is the length of all vectors which is equal, and that angle which is considered as alpha, beta, gamma, that are also equal, and that is considered as the 90 degree. So consider as first system which is considered as the cubic structure. And that system in this crystal structure, in this crystal structure, all the three length of the unit cell, all the three lengths of unit cell are equal at right angle to each other, at right angle to each other. Okay, so this is main condition in cubic structure. What is say that in this crystal structure all three lengths of unit cell which is equal. That means that vector length of vector a bar, b bar and c bar which are equal, that is vector a bar is equal to vector b bar is equal to vector c bar. This is main condition, and the angle between vector a bar, b bar, c bar which is considered as the angle alpha, beta and gamma which is also equal, that is 90 degree. So that next main condition that alpha is equal to beta is equal to gamma is equal to 90 degree. So these two are the main condition of this. Okay, and if we have to see here the detailed structure of this simple cubic which is considered as, for example, the length of the vector A, vector B and vector C which is equal, and the angle between alpha, beta and gamma which is considered as the 90 degree. So that structure which is considered as the simple cubic structure. So this is considered as vector a bar, this is considered as vector b bar and this vector which is considered as c bar, and we have to see that the angle between alpha, beta and gamma which is considered as the 90 degree, and all point of lattices which is situated on the corner of each cubic system or cubic structure, that is considered as the vertices point or corner point, and there are total 8 corner point. So this structure is commonly known as the simple cubic structure, or which is considered or we have to see that A, B, C that is considered as equal size, that have considered all side which is considered the A, and alpha, beta, gamma which is same at 90 degree. So that consider as this is simple cubic or denoted by P. Now in this simple cubic structure, again next structure which is considered as BCC, that is body centered cubic structure, and which is drawn by same this fashion. So consider as this cubic system, that identical points surrounding each of the corner points. So this identical point which is surrounded for each surroundings, so that the lattice point which is basically situated on the corner of each, and one point which has center of this face. So that structure which is considered as body centered cubic structure that is known as BCC structure, and that is considered by J. Now this cubic structure which has also one structure, so that structure which is considered as face centered cubic structure, and that face centered cubic structure having figure, see that here, because you have to know that there are total 6 faces in the cubic system, 6 faces in cubic system, and main condition which is given as here, so that is vector a bar, vector b bar and vector c bar, that length of all these 3 vector which is same, and alpha, beta, gamma, these are the 3 angle which is at 90 degree. So consider as in this structure, first of all this total 8 lattice point have identical in the surroundings at the vertices or corner of each cubic structure or cubic system, and 2 point in this face is exactly opponent of each, and other face point of each other, which is denoted by this different shape which is considered for here. And this structure which is considered as, because total 6 lattice point which is considered in this, so that structure which is known as face centered cubic structure, that is known as FCC structure, and that is denoted by the F, that is denoted by F. So this is the idea about the uh, first system of the three-dimensional space lattice which is cubic system, and that in this cubic structure all 3 lengths of the unit cell which are same, and the angle of alpha, beta, gamma which are equal, that is 90 degree. So these are 3 different cubic system considered as simple cubic system BCC structure, that is base centered cubic system, and next one which is face centered cubic system, that is FCC. Now we want to see the next main system or second main system which is considered as tetragonal cubic system, or considered as simply tetragonal structure. So we want to see here what is mean by tetragonal structure, or what is the relation between vector 3 non-coplanar vector, that is vector A, vector B and vector C. So next system which is considered as tetragonal system, tetragonal system, and that tetragonal system which is considered as, in this crystal arrangement all the 3 length of the unit cell are equal, all the 3 axes, in tetragonal system the 3 axes are at right angles, that is mean by the angle between ABC, that is angle alpha, angle beta and angle gamma which are equal at 90 degree, and 2 sides are equal and third side is different length for these 2 sides. So that is considered in this crystal arrangement. In this crystal arrangement 3 axes are at right angles. 3 axes are at right angles. This is first condition. Next condition, two sides are equal. Two sides are equal while other or next side, third side is different in length. While the third sides different in length. So this is considered as the tetragonal system. So that this definition we have to see here, the crystal arrangement, that three axes are the right angles, that is alpha beta gamma is equal to 90 degree, and two sides are equal, that is a and b, vector a and b, which are same, and third which is different length. So main condition which is will become, that is vector a is equal to vector b. So both vector are same, and third vector length is different, so that is vector a is equal to vector b and is not equal to vector c. This is main condition. And next condition for the angle between this vector, that is alpha is equal to beta is equal to gamma is equal to 90 degree. So this both are the main condition for the tetragonal system. And we want to see here the structure of this tetragonal system, which is considered as two types in this tetragonal system. First, which is simple tetragonal, and second, which is body centered tetragonal. So first, which is simple tetragonal, which is considered as so in this system we have to consider here the main point, which is two vectors length which are the same, that is vector a bar and b bar, which is same, and next one which is third side which is different from these vectors, so that consider as, for example, vector a and vector b, which are same, and vector c which are different from these both sides. So consider as this vector a, vector b and vector c. So both vector a, b and c both are same in length, and third vector which is different, and alpha beta gamma, that angle which are the same in angle, that right angle that is 90 degree, and this structure which is given as the simple tetragonal structure. Simple tetragonal, that is considered as P. And next structure which is, and all identical point lattice point which is situated on the corner of this, so that is considered as a simple tetragonal structure. And this vector ABC, that is considered as simply that vector A. Now next, which is considered as body centered tetragonal structure. tetragonal structure having same of this system of tetragonal, only one extra lattice point or extra dot point which is in the middle of this, so that is considered as body centered tetragonal system. So here alpha, beta, gamma, which are the same, that lattice point which are at the corner of this all point or the 8 corner, and one dot point is here. So that's why we have to say that body centered cubic structure and consider as the J. Body centered tetragonal. Body centered tetragonal. Okay, or simply consider here that this structure which is considered as because you have to know that the main condition between this which is surroundings, that two sides are equal, and third side which is different from each other, and that angle between alpha, beta, gamma which is 90 degree, and lattice point at each having identical surrounding in the corner, and one lattice point is middle of this, so that is known as the body centered tetragonal structure which is considered by J. So which is considered by I. So this is known as the tetragonal system. Next structure which is see here, the rhombohedral structure or orthorhombic structure. That orthorhombic structure information which is given, the crystal arrangement, three sides which are unequal, so that is considered as a bar. Vector a bar is not equal to vector b bar, is not equal to vector c bar, but the basically condition alpha is equal to beta is equal to gamma is equal to 90 degree for orthorhombic structure. And rhombohedral structure, that is vector a bar, b bar, c bar having three equal sides, and alpha and beta and gamma which are equal but is not equal to 90 degree. This is the necessary condition for the rhombohedral structure. And hexagonal structure which are the a is equal to b not equal to c, that is two sides are same and third side which is different, and two angles are same, that is alpha beta is equal to 90 degree and gamma is equal to 120 degree. So this is the basic idea of this system, two system which is described here, and out of this five system will be described in next lecture. So this is very important points for this subject. Once if you understand this point, so we have to get clear idea to find out the Miller indices and interplanar distance between these, which is get very clear for idea for the this point. So thanking of you.